Okay, in this video we're going to go over an important variation in conditional reasoning. So let's take a look at our statement. It says, the party was a success if and only if everyone had a good time. Okay, so what exactly does that mean? Well, it's actually a combination of two conditional statements. And this is one of the two conditional statements. It says that the party was a success if everyone had a good time. Here the necessary condition is stated first, and it doesn't have a necessary condition indicator. So the party was a success is the necessary condition. And this is the other of the two conditional statements. The party was a success only if everyone had a good time. Here, only the necessary condition has a necessary condition indicator, and it's only if. So the first part of the sentence, the party was a success, is a sufficient condition without a sufficient condition indicator. Now, in this case, the sufficient condition is also a necessary condition, and the necessary condition is also a sufficient condition. And this type of statement is called the biconditional, because in one statement, it actually has two conditional statements, where the sufficient condition is also a necessary condition, and the necessary condition is also a sufficient condition. So biconditionals always use the words if and only if. Looking at the if, that conditional statement has the necessary condition first and the sufficient condition second, and looking at the only if, the sufficient condition is first and the necessary condition is second. And here we've redrawn the first conditional to be a bit more straightforward. It says if the party was a success, then everyone had a good time. And underneath it, we've diagrammed its standard diagram and its contrapositive. Success followed by an arrow followed by good time. And the contrapositive is good time with a line through it followed by an arrow followed by success with a line through it. So the first conditional says that a successful party guarantees that everyone had a good time. In other words, you can't have a successful party where someone didn't have a good time. Everyone having a good time is a requirement for a successful party. Now here we've rewritten the second conditional to be a bit more straightforward. It says, if everyone had a good time, then the party was a success. And once again, we have our diagrams underneath with the regular diagram and the contrapositive to the side. And here the second conditional says that everyone having a good time is a guarantee that the party is successful. So here a successful party is a requirement for everyone having a good time. In other words, it can't be that everyone had a good time, but the party wasn't successful. As you can see from the contrapositives, if either of the conditions are negative, then the other one has to be a negative as well. Either both the conditions are true, that the party was a success and that everyone had a good time, or they're both false, that the party wasn't a success and that everyone didn't have a good time. So you're never going to have a situation where everyone had a good time, but the party wasn't successful, or where the party was successful, but not everyone had a good time. Like I said, either everyone had a good time and the party was a success, or not everyone had a good time and the party was not a success. And here's how we've symbolized it. The two-headed arrow lets you know that the conditions are both sufficient and necessary. So it's kind of like they're pointing in both directions. So on the left we have success, then two-headed arrow, then good time, letting you know that success is both sufficient and necessary condition, and that good time is both a sufficient and necessary condition. And likewise, we have success and good time with both of those conditions crossed out with a biconditional arrow in between them, bidirectional arrow in between them, and that's the contrapositive. And notice we didn't switch the two conditions. We didn't put success on the right and good time on the left. And that's because it would be irrelevant, because the arrow points in both directions. So whichever side you put it on is the exact same thing. Okay, so to recap, a biconditional is two conditionals taken together. The sufficient condition is also a necessary condition, and vice versa. And the conditions always have to go together in a biconditional. What that means is that they're either both true or both false if that conditional starts out with them both being true.